Hello everyone, welcome to the Algebra 1 Semester 1 review, which really isn't a semester final review. It's just over Module 2, which is everything that we've covered so far in January. Okay, so we have 3 topics that we're going to cover today, 10 questions on the review packet. So it looks like this thing where you got a bunch of problems on this side, you got a bunch of problems on this side, split into 2 columns. It's 10 questions, and I'm going to be doing the entire left side in this video, okay? So my tip for you is either try these ones first, okay? Try the right-hand side first. There's all of the same types of problems as the ones I'm about to do. So if you get stuck, you can sort of refer to this video as help, or you can ask me in person as well. We're doing this for the next 3 days in class, Wednesday, Thursday, and Friday. And so otherwise, you can just follow along on this video, take notes on the left side, and then try the problems on your own on the right. If you need answers or need to just check your work or anything, you can check in with me, or you can email me over the weekend, and I'll give you some tips or like maybe some help or just the answers to the review packet as well. Okay. Also, I want to apologize for the sort of quality of this video. It's probably the most scuffed recording that I'll do for this class because I'm currently doing it at school right before second period. So I have a time constraint on this one. So let's just get going. I guess one thing is I'm going to be writing on my tablet, which is making that sort of clicky clack ASMR sound. So I'm recording the thing, or I'm writing on the thing that's recording me talking. So the sound quality might not be as good. So I apologize for that. But hopefully, you can just get through it. Okay. Let's just get started with number 1, which is a multiple choice question. It's just asking us to determine the solution to each system. I'm going to warn you there is a typo on this question. It has to do with answer B. I think we'll see why in a second. But here's a definition that might be useful to you. Remember that a solution to a system, so a solution for a system of equations happens when the 2 lines meet. When the 2 lines meet, or maybe a word you might be familiar with is intersect, where the 2 lines intersect. Otherwise, it's really just saying, where are they the same? Where are they the same? Okay, so in most cases, that will mean just where they cross, which if I look at my graph here, I can see they cross at one singular point, which is not too uncommon. And really what I'm going to do is just figure out where this point is, and that's at negative x, or negative 1 in the x, negative 1 in the y. So this must be negative 1, comma, negative 1. Which if I look at my 4 answers is not actually as written one of the solutions, but B was what it was meant to be, and I just forgot to change it. Okay, so anyway, as we keep going into the next problem, this one though, if I look at it, is a little bit funky because if I'm just trying to figure out where the 2 lines cross, if I continue these out forever, I would have a suspicion that they would never cross because they are what we call parallel, right? Parallel. These 2 lines have the same slope, but at different points. They will never meet up 1-to-1 next to each other. And so the answer to this one is no solution. There's no point where these 2 lines are the same, okay? The other option that isn't actually in one of my examples is when there's an infinite number. And that happens when there's 2 lines on top of each other, okay? So an infinite number of solutions happens when it's the same line in the system. So for instance, if one of my lines was blue and the other one of my lines was green, these 2 lines, they're both infinitely long, they extend out forever, would have infinite solutions because they're always the same line, right? They're always meeting each other. Okay. Next one. So we've done it graphically. We looked at two lines and figured out that's where they cross. That's the point where they're the same. If we want to do it algebraically, which we've done a lot, specifically using elimination, then really what we're doing is we're finding that coordinate point. We're finding that x comma y where these two lines meet up. Because these really are just two lines. These are just two linear functions, just in standard form. Okay. And remember, your goal with these problems, sorry, that's the bell. Your goal with these ones is that you want to add the equations together. Holy moly, equations together and cancel something out. And cancel out an x or a y. Cancel an x or a y, okay? So your first good step is to just try to add them together. And what I mean by that is just like you're in grade school, you're just adding things left to right. You add your x's to your x's. And so I'm just going to say 3x plus negative 6x, which is really 3x minus 6x, which is negative 3x, okay? And then 7y plus negative 7y, that's just 7y minus 7y, which is 0y. And then negative 8 plus 23 is 15, I think, okay? Let me double check in my head. Yeah, that's right. Okay. Now, though, because my 7y and my negative 7y were added together, these two things, these two numbers, are what we call additive inverses. The less fancy way to say that is they're opposites, right? The opposite of 7 is negative 7, at least when you're adding, okay? So when I combined these two equations, I got a new one, which is still a part of my system, but now there's no more y's because it's 0y, right? And so really all I have is this equation, negative 3x equals 15, and I have to solve for x. I need to cancel this negative 3. The negative 3 is multiplying x since they're attached, so I'm just going to divide both sides by negative 3. And that tells me that x equals 15 divided by regular 3 is 5, so 15 divided by negative 3 is negative 5, okay? So I'm not done yet, though, because that was really step 1. Step 2 is what I just did here, which is solve for your first variable. So in our case, we found x because we combined the equations, right? We canceled out the y's, and we were left with an equation that just had x, which is solvable, okay? And then what you want to do, step 3, is plug that value back in to one of the equations and solve for the other. Okay, so what I mean by that is I now know what x is, right? X is just equal to negative 5. Like in this system, the way to make it the same will only ever happen when x is negative 5. So I actually don't really need to write x anymore. I can just say that x is equal to negative 5 because it is. And so I'm going to go back into one of my two equations up here. Whatever one looks simplest to you, which in my opinion is the top one. The number is just smaller. There's fewer negatives. But it really doesn't matter. Either one works. And I'm going to rewrite this first equation, just in this case because it's easiest, except for every time I see an x, so instead of writing 3 times x, I'm going to write 3 times negative 5, right? They're the same value now. X is just negative 5, so I can rewrite it as that. And then I keep everything else the same. Plus 7y equals negative 8. And now this is like a two-step equation that we can solve for y, okay? So we just have to simplify this. 3 times negative 5, what we just did over here was negative 15. And then plus 7y equals negative 8. I need to take 2 steps to get y by themselves. So first, I want to get rid of anything that's not attached to a y. And so I'm going to add 15. and I get 7y equals negative 8 plus 15 is 7. On this side, I added 15 because this 15 was negative, so they cancel. And now I have 7y equals 7. I'm going to divide both sides by 7, and that tells me, well, both of these cases, they just turn into 1. So y equals 1. And that's my answer. So really, my final answer and what I would put on the test, there's going to be a little box that says x equals y equals, and you write it in. X equals negative 5, y equals 1. Okay, cool. Let's go on to the next one, which this one isn't so nice because when I looked at my top equation, I just added them together and it worked. It canceled the y's immediately because I had two opposites or additive inverses already. In this case, though, when I look, I can see that there's no opposites directly in my system, which means I need to do a little bit of work before I can add these together to cancel something, okay? So really what I'm doing in this problem, if it's a little bit more tricky, I want to multiply an equation to create an additive inverse or an opposite, okay? And so what you have to think about is there a way to turn one of your variables into the opposite of the other thing below it or above it, right? So like when I'm looking at this 2y and this 9y, well, I know that 2 can't go into 9, so it's really not going to be that easy to do. So I'm actually going to look for the x's because 5x can in fact turn into 15x, right? So I'm looking at this 5x, which means I want to multiply the top equation by something, and I have to multiply everything in the top equation by this thing. And if I want to turn 5x into 15x, I would have to multiply by 3. But because I want to add them together and cancel, that means that one of my values has to be positive and one has to be negative, right? I need these to be opposites. So in fact, since this one's already positive right here, I'm going to multiply both sides of this top equation by negative 3. And what that will do, I'm just going to rewrite it here. What that will do is I distribute this negative 3 in, I multiply the negative 3 on the right side as well. And so I get negative 15x minus, well, negative 3 times negative 2y is actually a positive because a negative times negative is positive. So plus 6y equals, and then same thing, negative 3 times negative 10. Well, the negatives cancel and I'm left with just 30. Okay. And now what I want to do is just add this equation now, this one on the top, is basically just this one on the bottom. And I'm going to add this equation to my new equation, the one I multiplied by negative 3, and let's see what happens. Okay. So when I add these two up, 15x and negative 15x cancel, which is good. I'm not even going to write anything. Negative 9y plus 6y still leaves me with a negative 3y, and then 0 plus 30 is 30. And now, that's just pretty cool. I'm one step away. I canceled my x's, so that worked. And now I'm really on step 2. So solve for my first variable. And I'm going to do that by dividing. Dividing by negative 3 to both sides, because the negative 3 is multiplying y. And I get y equals negative 10. 3 goes into 30 10 times, so negative 3 goes into 30 negative 10 times. Okay, so I'm halfway there. And now what I want to do is go back and choose one of the easiest equations, or whatever you think, which in my opinion, because of this 15, I'm going to go for the top one. 15 and the negative 9, that's scary, even though there's a 0. So I'm going to multiply, or I'm going to just choose this top equation before I multiplied it by negative 3, except now I know what y is, right? So y is negative 10. And so when I go back into my top equation, 5x, whoa, my pen is freaking out. Oh no. Okay, relax. Okay, 5x minus 2y equals negative 10. Remember, I'm doing this before I multiplied because it was simpler. Except now I know that y is my, oh no, my eraser doesn't work. Hold on. No, please stop. Okay. Instead of writing y, I know that y is now negative 10. So I'm going to substitute it in. And now I just need to simplify and solve. So negative 2 times negative 10 is positive 20. So this becomes 5x plus 20 equals negative 10. I'm going to subtract 20 to both sides to get x by itself. So I get 5x equals negative 30. And now I need to divide both sides by 5. And I get that x equals negative 30 divided by 5 is negative 6. And so my final answer is x equals negative 6 and y equals negative 10. Cool. Okay, that's the point where these two meet. One last one. This one is really tricky because if I look at both of these numbers, neither of them, or my x and my y's, neither of them can easily go into the other, right? So what I'm going to have to do is actually multiply the top equation and the bottom equation by something. And so when I'm going to do this, I'm going to choose the smallest of the two numbers, okay? Which means I want to do my y's. I want to cancel out my y's, all right? Well, the easiest way to do that is because I can turn 7y and I can turn 2y into their lowest common factor, right? The thing that both of these numbers can go into, which is very often just the numbers multiplied by themselves. So really, the lowest common factor between these two is 14y, okay? So my goal now is to turn one of them into 14y and one of them into negative 14y. And you do that by multiplying the top equation by the bottom. So I'm going to multiply everything in the top by 2. And then I'm going to multiply everything in the bottom by negative 7. That way this 2y turns into a negative 7y, okay? So I'm going to have to rewrite my whole system because I'm multiplying two equations, but, oh man, why is my eraser working? Hold on, let me fix this real quick. Still not. Okay, well, that's okay. Anyway, there's like a dot there that's bothering me. Let me get rid of it. Okay. So I'm going to just multiply. So I have to multiply 2 to everything in the top equation, and then negative 7 to everything in the bottom equation. So 2 times negative 9 is negative 18x. 2 times 7y is plus 14y equals 2 times 14 is 28. And then on the bottom, negative 7 times negative 7x is 49x. Negative 7 times positive 2y is negative 14y. Ugh. Negative 14y equals 7 times 4 is 28. Negative 28, okay? So what's going to happen here, I think 7 times 4 is 28. Yeah, that's right. So now what I'm going to do is just add these equations together. And even though I have some big x values, my y's are going to cancel. And then something else is going to cancel too, which kind of is nice, okay? So I know my y's go away. I know my right side, 28 minus 28 is 0. And so negative 18x plus 49x is 31x. Okay? Remember, you're going to have access to a calculator too if you need. And a lot of people might think that this is no solutions because it kind of looks wrong, right? But really, if I think about it, there is a value of x that can make this equation true. It just happens when x multiplies 31 and turns it into 0. The only way for that to happen is if x equals 0. So in other words, you could just divide both sides by 31. But 0 divided by 31 is just 0. So these will turn into 1x, but this is just still 0. So x equals 0. Okay? Whenever you see that, you actually should be a little happy because plugging it back in makes your life a lot easier. I'm going to go into the bottom equation because I think that's easiest. Except now, I have negative 7 times 0 plus 2y equals 4. Oops. But anything times 0 is just 0. So this is all gone. And I'm really just left with 2y equals 4, which I can divide both sides by 2 and see that y equals 2. And so my final answer for this one, after a bunch of work, is x equals 0, y equals 2. Okay. Moving on. This one is like a word problem of the same thing, solving systems. Remember, I told you this is the most important topic. That's why we spent 2 weeks on it. So if you're still remembering how to do it, hopefully it comes back. But I know a lot of you guys worked really hard on remembering it or learning it the first time. Okay, so for these word problems, really what I'm trying to do is set up my system. That way I can just figure out when they're equal by doing some elimination or something like that. okay? So when I'm reading this, I want to figure out the important things. My first goal is I'm just going to highlight every number I see, okay? So the first thing, the freshmen want to plan a pizza party, but they want to decide what is the best value for their money, right? They don't want to waste too much money. And so they're considering 2 pizza deals, okay? That signifies to me there's going to be 2 equations. Pizza House, we'll do in pink, or I guess red, charges a $10 delivery fee plus $5 for each large pizza. That's actually crazy. Like that is so cheap. Hungry Howie's charges $15 for a delivery fee plus $4.50 per large pizza. That's also insanely cheap, okay? Well, what does that mean? My first equation, which was Pizza House, okay? Their total amount, which we'll call like Y, their total amount is $5 for each large pizza. So we'll say $5 per pizza, 5 times P, plus a $10 delivery fee, which that $10 delivery fee you only ever get charged once. So it doesn't have a variable, it's just a constant. It's kind of my y-intercept, okay? And then for Hungry Howie's, I'm going to say y, which is my total cost. I guess I can just use a different variable for total cost. I could just say C for costs. So C for costs. Oops. C for cost equals $4.50 per pizza, 4.5p, plus a $15 delivery fee. Okay. Well, at how many pizzas are these 2 deals equal? We can actually solve in a couple of ways, okay? Number one is you're going to have access to your graphing calculator. You could just graph these and find where they cross, right? We could also graph them by hand and find where they cross. You could also like guess and check some numbers. You could plug some stuff in, or you could also use elimination just with a little bit of a trick, okay? So really my 2 equations for my system are this. C equals 5p plus 10, and C equals 4.5p plus 15. Well, if I add these 2 equations together, I'm almost going to cancel out the costs, the C's on the left, okay? I just need to make one of them negative. So right now, I'm just going to turn everything in the bottom equation into a negative. That way, when I add them, the C's will cancel. Really, what I'm doing is subtracting the 2 equations, but that's the same thing. Right? So first I multiplied everything by -1. So I just made everything negative. Multiply by -1. When I add these 2 together, the C's are going to cancel on the left side. I'm left with 0 equals 0.5p minus 5. Okay? So 0 equals 0.5 per pizza minus 5. At this point, the logic and like what the real equations mean, or the numbers mean, the letters mean rather, don't really matter because we're just solving. And I want to get p by itself. And so really, I'm going to add 5 to both sides here to get rid of this -5. And I get 5 equals 0.5p. And on your calculator, what I would do is I would just divide both sides by 0.5. Now, 0.5 is just a half. Dividing by a half is the same as multiplying by 2. So really this is p equals 10, which means when there's 10 pizzas, there are 10 pizzas, the costs are the same. Cool. Okay, you can do this in multiple ways. I bet most people could guess and check that one, which I think is an awesome way to solve this problem. I'm cool with you doing that on the test. You do not have to cancel out the C's on the left and eliminate. Although, if you're familiar with what we just did in the last 3 problems, then it might be easiest to do it that way. Or you could use a table, plug in some values, or you could graph it on your calculator. Either one works, okay? Same thing for this one. Let's figure out how we're going to do this whole problem. This time, though, I think it's going to be a little more apparent why we're going to eliminate, okay? So Here's the thing about this equation or this word problem. Once again, I'm still going to highlight every number to start and then write my equations based on the numbers that I have highlighted, okay? So the senior class from Star Valley High School and Junction High School, so that's 2 high schools, shows me that there's going to be 2 equations, are planning a separate field trips to the local amusement park. A total of 337 students from Star Valley will be going in 1 van and 7 buses, okay? A total of 809 students from Junction High School will be going in 11 vans and 14 buses. Assuming each van and each bus carry the same amount of students, we're going to figure out how many students fit on each van and each bus, okay? Each van and each bus carry the same amount of students. Write a system of equations that represent this problem. Well, what I'm going to do is just take all of my information from the problem and turn it into an equation, okay? So when I look at my green, the Star Valley, okay, I know that they're taking 1 van. I'm going to call that 1V, 1V for van. And plus means and. They're taking 7 buses, so 7 for B, or B for buses, so 7B. And the total number of students they're taking, so 1 van and 7 buses are taking a total of 337 students, right? I've used all my highlighted numbers, and I've made an equation, okay? I can use the same logic for the second one. They're taking 11 vans this time and 14 buses, but they're taking more students. They're taking 809, okay? And now I have this system of equations. The only difference is that instead of using x and y, like in the top problems, or I guess in the problems from the previous couple answers, I'm using v and b for vans and buses. So v is van, b is bus, okay? And then my numbers on the right are a little bit bigger, but I bet we can get through it, okay? So solve the system using elimination, show your work. Well, if this is our system, right? If we have 1v plus 7b equals 337, and I have 11v plus 14b equals 809, what you can do is realize that b's, the buses, can go into one another kind of. Like, oh no, my eraser. I can turn 7b into the opposite of 14b if I multiply both sides by -2. That's what I'm going to do. So my new system, or my new equation, is going to be -2 vans and -14 buses, although plus negative is just a negative, equals, let me do this in my head, 674. 674, okay? I'm going to need a calculator to subtract these, though. Oh, I have one right in front of me. Cool, okay? But now I'm set up to just combine these systems, right? I can just add these 2 equations together. So the v's, 11v plus -2v, leaves me with, in total, 9 vans. The buses cancel out, but the students, 809 plus, no, what happened here? Oh, -674, sorry, because I multiplied this by -2. So 809 minus 674 is 135. That seems like a correct number to me. Let me double check that 337 times 2 is 674. Okay, it is. And now I know that 9 vans can carry 135 students, which means if I divide both sides by 9, I can see that 1 van, 1v, can carry 135 divided by 9 is 15. That's this. Okay, 135 divided by 9 is 15. So I know that each van carries 15 students. So now I just need to figure out how much does each bus carry, and I do that by taking one of my equations. I think the top one's simplest, the Star Valley, except for now I know that a van can take 15. So in this top equation, I know that 1 van is just 15. Since I had 1v before, I just have 15 students, plus 7 buses equals 337, and now I have to solve for b. So I'm going to subtract 15 from both sides. I get 7b equals 337 minus 15 is 322, and then divide both sides by 7. and I get B equals 46. So what that means is each van can take 15 students, and each bus can take 46. Cool, and that's how you interpret the answer. All right, next question. This one's a multiple choice, and it has to do with an inequality, okay? So we just have to read what this means. We have to do a little bit of thinking on what the inequality might be, and then we have to match it to one of the answers below, okay? So let's see if we can do it without even looking at the multiple choice things since they're not on the screen. So I know that I'm highlighting every number. A Helping Hands program received $250 for helping the community. The program has a goal to reach at least Y dollars by the end of the month. They receive $50 in donations each day. Which inequality represents the solution where X is the number of days? Okay. Well, if they make $50 each day and X is 1 day, or X is the number of days, X is, I guess, just days, that means that one of my sides of my equation is just going to be 50 times X, okay? I also know that they just received $250 just plain, like no condition on that. They don't get that every day. They just got it one time, which means in addition to this $50 for each day, they got 250, okay? And now I know that this is one of my sides of my equation. All I have to think about is, do I want to have a greater than, less than, greater than equal to, less than or equal to sign in this inequality? I know that I want to raise Y dollars. Y is just some random amount, so we leave it as Y. But since I want to raise at least Y dollars, I know that my total value, which is represented by this thing, the 50x plus 250, hopefully it's greater than Y, but because it says at least, I'm also satisfied with meeting exactly Y. And so using the greater than or equal to sign represents this because the total amount of money, $50 per day, since X is days, plus the 250 just grant that I got or whatever, helping the community, hopefully that is greater than or equal to, in other words, at least Y dollars. And that is answer this one, I guess, right? Wait, is there another typo? I'm so mad. Oh, I think this is another typo. Sorry. Okay, well, this should be the other way, I think, because this one should be this one. No, wait. Yeah, it's a typo. Might be. Dang it, that's really annoying. Sorry, I should have edited this. I had the opportunity to. So it is answer D because that only matches the inequality, and then or it matches the side of the inequality, the 50x plus 250. The inequality sign is wrong. I'm gonna make sure on the test that there isn't a typo, and then I'm gonna make sure that the right side doesn't have one either. But dang, that's another typo. Okay, anyway, let's move on. This one's kind of fun. We have two pictures of a graph, and we want to figure out what the equation is of the line, and then using the shading that they did, figure out the inequality. And so really, we're creating our own y and mx plus b. So like we're doing our own slope-intercept form. The only difference is that this is going to be a greater than sign or a less than sign or something like that. Okay, so there's going to be an inequality in between. So remember, I need to know what the slope is first. So the slope is m. That's my rise over run. In other words, that's how far I go up and down. So my up slash down over how far I go to the right. That's my run. Okay, so these are the two of the same. And the way I do this to figure out the slopes is to just find a nice point, or find two nice points. And what I mean by nice points are points that directly go through one of the grid lines. So when I look, I can tell that this first blue dot directly goes through this grid line at -2. And then this dot right here goes through the grid line at 4 comma 1, okay? Well, all I'm doing for the slope is I'm going to count up how far up I have to go to get to this next blue dot. I have to go up 3, and I have to go right 1, 2, 3, 4, right 4, which means my slope, m, must be 3 over 4, okay? Which means m equals 3 over 4x, or I guess my slope is 3 over 4, so my equation is y on one side. I don't know the inequality yet, 3 over 4x, and now I just need to use b, which is the y-intercept. That's where it crosses the y-axis, which was one of my nice points. That's the y-int, and it happens at -2, which means in addition in my equation, I'm subtracting -2, okay? So this is the equation of the line, but now I just need to figure out what sign to put here that represents the shading, and then whether or not the line is solid or dashed. Since this line is solid, I know that my equation, or my inequality, is going to be or equal to, it's going to have this line. And then when I look, I'm shading below my line, which means all the y values I care about are below or less than this boundary. So really, this is my final answer. Y is less than or equal to 3/4 x minus 2. Okay, next one. This time we're shading above, it looks like, and then our dashed line, or our line is dashed rather than solid. But first, let's just find the slope anyway. So first, let's find the slope. Here's a nice point, another y-intercept, but I have to get to this nice point, which means I have to go down to right 3. Oh, what did I do there? Right 3. So down to right 3. That means my slope is -2 because I'm going down, but still over 3 because I'm going to the right. Okay. So far I know y on the left side. I don't know the inequality yet, but I know that something is -2/3 x, and then my y-intercept is right here, which is at +2 this time, and so I'm going to throw in a +2 because that's my y-intercept. And then because I'm shading above, I know that my symbol is going to be greater than. All the y's are greater than my line or above it. But this time, because my line is dashed, it tells me I can't actually be on my line. And so I just leave this inequality the same. I don't write the or equal to. So that's the answer. Okay. So really, you're finding your slope using the nice points, and you're using the y-intercept wherever it crosses the y-axis up and down as your b value. And you're creating the equation. Okay, this one you got to jump ahead a little bit because I sort of spaced this out weird. So this is like material ahead of what we learned, or like we're out of time here, but that's okay. Really, we're solving these for x. And so if you've been gone, this is what we've been doing the past couple of days. Really, your first step is to isolate the absolute value. Isolate the absolute value, okay? What that means is I need to get rid of anything that's not inside of it first, okay? So when I look at this one, there's a -2, and this -2 is actually subtracting, right? It's like not connected to anything. It's just hanging out. It's just something -2. And so to cancel it, I'm going to add 2 to both sides, okay? And then that leaves me with absolute value of x minus 7 equals 4, right? 2 plus 2, those sides cancel. And now to solve this, I need to think about what the absolute value function does, okay? Remember, when I plug something into an absolute value, if it's negative, it just spits out the positive version of that number. If it's positive, it keeps it the same, right? So really, I know that this problem right here, x minus 7, right? I want the absolute value of this thing to be equal to 4. Well, the two ways for that to happen is if x minus 7, the inside of my absolute value, just equals 4, right? Positive 4. Let me do that in black. Equals 4. Or, because it's in the absolute value, x minus 7 could equal -4 as well. So really what I'm doing in each of these is I will have two solutions for x. The one that makes the inside of the absolute value positive, and the one that makes the inside of the absolute value negative. because either way, because you're taking the absolute value, it spits out a positive, okay? And what's cool about these is that you always do the last same step. Your numbers will just be different, okay? And so really, I get x, and then I add 7 to both sides to cancel out those. Minus 7 equals 4 plus 7 is 11 in this case. And then this one, x, these 7s cancel, but negative 4 plus 7 is 3. So I have 2 separate answers for x. Both make this equation true. And those are my 2 final answers, okay? Let's go on to B. We're going to use the same logic. I still want to isolate the absolute value. So this time I need to get rid of this negative 2. Except this negative 2 is not just hanging out. It's not just being subtracted. It's actually attached to the absolute value sign. And when it's attached to something like parentheses or absolute value, that means it's multiplying. And so I need to divide both sides by negative 2. Okay. That means on the left, they're going to cancel. And I'm left with just the absolute value of negative 5x equals negative 30 over negative 2 is 15. Negative times a negative is a positive, same as dividing. And then I use the same logic. I know that this inside, negative 5x, well, if it's positive 15, then the absolute value of it is 15. Or if negative 5x is negative 15, that'll also work because I'm taking the absolute value of it. In both cases, I'm going to divide by negative 5. They cancel on the lefts, so I'm left with just x's equals, in this case, 15 divided by negative 5 is negative 3. And then this time, x equals negative divided by negative is positive, so positive 3. So my 2 values of x are negative 3 and positive 3. Make it true. Okay, so big idea with this one is splitting them up. All right, we're almost there. This time we're going to graph our systems of equations. So we kind of jumped back to what we were just doing. And then we're going to shade to find the solution. And then we have to describe some points that are in our solution area. Okay, so remember, slope-intercept form is your slope is your b value. It's whatever's multiplying, or your m value. It's whatever multiplying x. So in this case, the slope is negative 3/2, which means I'm going to go down 3, right 2. And where do I start? Well, I always start at the y-intercept. That's the first point that I know. And so I know that on this graph, and I'll do this one in red, my first point is at 1, because that's the y-intercept. And every consecutive point is down 1, 2, 3, right 2. Okay? So that is the 2 lines that I need, or the 2 dots that I need to draw my line. You only ever need 2. But when I connect this, I need to take a look at the inequality sign. Because it's strictly greater than, because it doesn't have the or equal to line, that means I can't be equal to this line. And so I'm going to make it dashed to represent that it is a boundary, but I don't include it. Okay. Same thing for this one. I'll do this one in blue. This slope is 1/2. So that means I'm going to go up 1, right 2. And I start at negative 3. That's my y-int. Okay. So I know my first point is at negative 3. Every next point is up 1, or up 1 over 2. Up 1 over 2. And this one is also dashed. Okay. Now for the fun part, the shading. I need to shade because both of my symbols are greater than. This one's greater than, this one's greater than. I need to shade above both lines. Okay. Well, I can see that above my red line, and I'll do this in pink highlighter. Above my red line is all of this area. Everything above my red line. Okay. Above my blue line is all of this area, everything above my blue line, right? I'm just shading everything that's greater than that thing, which means all of my double shaded area, this sort of dark blue line, or this sort of purpley, is my solution area. And so to find 3 points, I just pick 3 nice points that are in it. I like this one, and this one, which are 1, 1, 2, 1, and 3, 1, right? The x value is 1, 2, and 3, and the y value just stays 1. So those are 3 answers that are in this solution set, okay? Same thing for this next problem, but I know we practice this a lot, so I'm going to give you an extra one to do. Nah, I'll do this one. Okay, so this one, the slope is -2. Okay, and the y-intercept is 3. So that means my slope is really -2 over 1. So every time I'm going to go down 2 and right 1, and I start from +3. Okay, so that's my first point. I go down 1, 2, right 1. Down 1, 2, right 1. And when I draw this line, this time, it's a less than or equal to. So this one has the or equal to, which means I just draw this line filled in solid completely. Okay, so it's like that. This bottom equation is like almost the same as what we just did, except for it's at -2. And so this one is this is the slope. It's up 1 over 2, or up 1 right 2. And then this equation has a y-intercept of -2. So I start at -2 and I go up 1 over 2, up 1 over 2. This time it's not equal, so I use a dashed line. So I'll do that here, right? And in this case, I'm shading below both. So that means below my blue line is all of this stuff. Below my red line is all of this stuff. And so my solution area is this double shaded area right here. 3 points that are in that. I can see, let's do this one, and this one. I like just keeping the x's the same. So my 3 solutions would be 0, -3, 1, -3, and 2, -3. I'm just picking random points that are in this solution area. Really, it's just a test of figuring out, do you have the right area, right? So identify 3 solutions. So these 3 answers are solutions. Okay, we got 2 more. Whew. Actually, I'm going to skip this one. I'm running a little bit low on time. No. We're going to do this one. We have time. Oh, it's actually not this one's not too bad. Okay, so another story problem, another word problem. So here we go. I'm going to highlight every number. This time, this is like a classic math problem. You're going to see this on the SAT or whatever, where you have 2 gym memberships. One has a monthly fee and a starting fee. The other one has, well, they both do, but one is like larger than the other. So maybe it's cheaper for a long amount of time, but you have to pay a higher initial fee. So when I look at like the fitness club, they have an initial fee of $50 plus $5 a month. These are insanely cheap for gyms, by the way. Like gyms are like $50 a month sometimes. The workout zone charges an initial fee of $20 plus $10 per month. Okay. Oops. And so what that means is we just need to make some variables. Let's represent C as total cost. And let's represent M for month. Monthly charge. Okay. So the fitness club, its total cost, C, is equal to $50. So 50 plus $5 per month. 5 times M, right? It's kind of the same pattern as we saw in that Hungry Howie's, the pizza one. For the workout zone, the total cost C is $20 initial fee, which you're only charged once, right? So it doesn't have a variable, plus $10 a month for that. So plus 10, that's an M, I guess. Plus 10M, okay? Well, if we graph these and figure out where they cross, then we can just answer the problem, right? We don't have to do any elimination. We don't have to do anything like that. We can just graph to solve. Okay, so I'll copy them down over here once again. It was, for my first equation, And I'm going to write them in slope-intercept. So I'm just going to flip the things around, but it doesn't really matter. So 5m plus 50, just because we're more used to seeing it that way. 10m plus 20. It's really the same thing. Like we can flip these around however we want. Okay. So our first line, which is the fitness zone, or what was it? The fitness club. Its initial fee is $50, which from a graph, that's just the y-intercept, right? Our initial fee is just the y-intercept. The initial fee is just the y-intercept. And then my monthly charge is my slope. It's my slope. Okay. So I know that my first fee is $50, and I go up 5 every month. So when I look at my x scaling, these are my months, and this is my charge or cost. Okay. I start at 50 because that was my initial value, and every month I go up $5. So really I'm saying the slope is up 5, right 1. So I'm going up 5, which is halfway between these two 10 values, up 1. So all of these points. And I would just connect the line like that. Okay. My second equation, the workout zone, has a lower initial fee, but a higher slope. Every month I go, this one is up 10, right 1. So I go up 10, right 1, up 10, right 1, up 10, right 1. Okay. And so if I continue these out, I can see, that was bad. That was bad. Here, let me just use like the tool that's built into my computer that draws straight lines. Look how nice that was. Okay. And then let me drag this green one down. There we go. And I can see that they cross at one specific point. They cross right here. Those are the value where it's the same, right? And in fact, the green line, the fitness zone or the fitness club, is more expensive for the first 6 months. This happens at 6 months. And it happens when they both charge $80. So that's the point where they meet, 6, 80. And so I have to analyze this cost. I would say the fitness club, the fitness club is more expensive for the first 5 months. Okay. And then they are the same because that's where they meet. So then they are the same at 6 months. Then the workout zone is more expensive. So which one's better? Workout zone for less than 6 months. Fitness club. Fitness club for more than 6 months. And if you have a gym membership for exactly 6 months, it doesn't really matter in this case. Both are the same for that 6 month. Okay. I'm probably going to go over this one in class too, just because I think it's really cool and it's a useful thing that you might be able to figure out. Okay, last but not least. And don't disregard these sort of black lines. They just kind of got put there on the PDF for some reason. I'm sorry. Okay. But here we go. Ooh, okay. So on the whiteboard right now, there are 3 sort of columns that have some transformations, okay? And I really want you to write these down on your note sheet. So when you get your note sheet, I'm going to tell everybody in class to just write down the thing that's on the board into this space, okay? But these things on the inside, this is your left and right. And weirdly, so that's your horizontal rather. I don't know why I said left and right. I guess I'll say both. So this is horizontal which is left/right, and this is your vertical, which is up or down. Except the weird part is that the horizontal ones do the opposite. When you go -3, that's actually to the right. But when I say +2 on the outside, so not in the absolute value, that's actually up 2, okay? And so really what you have to know is that the initial absolute value function is just a v, right, with the slope of 1 on either side. And so let me make some axes here. What the? Can you not? Thank you. And I know that originally my v goes like this, right? It's at the origin. But in this case, I'm going to shift 3 to the right and 2 up, which means my new vertex is right here. And so my slopes, my line is like that. And it's simple as that. You just have to know what the transformations do, okay? So really, it's important that you get those notes from the board onto the sheet right here, okay? And then the only thing that's different about this one is that there's a minus sign in front. What that does is reflect or flips upside down. Okay, it takes everything and it flips it upside down, meaning that your V is going to point downwards. Okay, and so really the two things that are happening is I flip upside down and I go down 3. So if here are my axes, oops, that's bad. This is my axes, this is my axis. I'm going to start originally here, but I'm going to shift 3 down and point both lines down. And that is the bell. Perfect timing. Students are about to walk in to second period when I post this video. Thanks for watching, guys. See you next time.